Okay, so the next topic is AVL tree deletion, but I couldn't create a new slide for that, so I will just use this board. AVL tree deletions. Okay, so how to delete values from AVL tree, and uh, in order to make a valid tree, how to balance that imbalance AVL tree when you are after you deleting a node. So those are the topics that we are going to cover in this episode. So sorry, I couldn't make a new slide for that, so I will just take some random example. So 10, maybe 5, and let's say maybe 11 or maybe 12, and 11 and 13. So let's say this is 4, maybe this is 7, and maybe this is 3. Let's say maybe this is what, 50. So let's say this is our initial AVL tree. So let's delete some nodes, then we can see how to perform the corresponding AVL cases, how to perform corresponding AVL tree balances depend on the particular cases. Okay, so you know what are the particular cases. So let me write it again. So left case, right case, and the left case, and the right case. So in order to perform left case, we must perform a right rotation. In order to fix right case, you must perform left rotation. In order to fix left case, you must perform a left and right rotations. In order to fix left case, you must perform right and left rotations. So those are the four cases when we encounter in AVL trees. So I've discussed each and every cases in the previous videos. So if you don't know about these, please look those as well. Okay, so let me continue the example. So first let's delete 3. So I'm going to delete 3, so it will make my AVL tree something like that, like this: 7, 12, 11, 13, and 15. So still we are okay because balance factors are 0, 0, -1, 0, -1, 0, 0, 0, and -1. Still we are okay. So let me delete 4. So it will make my tree like this: 5, and so there is no value. So 7, 12, and 11, and 13, and 15. So again, it seems still we are in the safe side because balance factors are still okay. Okay, now let me delete 7. So if I delete 7, corresponding AVL tree will look like this. But now let me see the balance factors. Okay, 1, 2, and this is -2. Now we got encounter imbalance over here. So what is the specific case? This is the specific case, right case. But someone can ask, is it not the right left case? Okay, and in the previous video I explained this one as well. So when you are finding the corresponding case, you always check what is the corresponding subtree which will make the binary tree, which will make your AVL tree imbalance. So if you see this leaf node, this is not a particular node which makes your AVL tree invalid, which make your tree imbalanced, because this is just 0. But when you see this node, this will make 32 minus 1, and this node will make the 12 as minus 1, its balance factor, and this node is giving some additional height to this specific subtree, so it will make this node having balance factor of minus 2. Okay, so this is the node which makes this 10 as imbalance. Okay, so that is the way you find out the corresponding case. Otherwise you can't just perform a random case, just perform fixes for random cases. Okay. You always must find out the corresponding and correct uh, case, otherwise you will be in trouble. So right case, so I must perform left rotation over 10, so 10 will go downside and 5 and 11 will be attached to 10, and 12 will be the new root. 10, 5, 11 and 13 and 15. So I explain how to perform these rotations as well. So if you don't know about such stuff, please first watch the previous videos. So leaves are always having balance factor of 0. This is 0, this is minus 1, and this is 0. So our tree is again balanced. So I can delete more values. So let me delete maybe, let's say what I'm going to delete. Maybe let's say I'm deleting 15. So it will make my tree like this. 5, 11 and 13. So balance factors something like this. And let me delete 13. So it will make my AVL tree something like this. Some left bias tree. So balance factors are again 0, 0, 0 and 2, because left height is 2 and right height is 0, so balance factor is 2. Now what is the case? Is it left case? Is it left case? Or is it left right case? So here is the thing. This is some kind of a case that we can both left case as a valid case, or maybe left right case as a valid case, because if we see the specific order of this node, this makes a tree balance itself, this makes tree imbalance itself, and this make tree imbalance itself as well. There is no any difference. So such a case we can either choose left case or left right case. So let me show you the both cases. So suppose if I take left case as a valid case, so if I choose left case, I must perform right rotation, right? So it will make my tree. So let me draw my tree again, or maybe let me erase this. Okay, so if I choose left case, I must perform right rotation over this 12. So it will make my tree look like what? So 12 will go downside and 11 will be attached to it, and 10 will be the new root. So 10 will be here, 5, 12 and 11. So let me consider the balance factors. So 0, 1, 0, minus 1. So see, we are balanced. And suppose someone took left right case as the valid case. So left right case. So if a person choose left right case, First, we must perform left rotation over this 10, and then he must perform right rotation over this 12. So first, suppose if I perform a left rotation over this 10, so it will make 5 and 10 to go downside and 11 will to go upside. So it will make my tree like this. So 10, 11, sorry, 12, 11, 10 and 5. Okay, so it's completely a left bias tree, but don't get confused. Now we must perform right rotation over this 12. Okay, you are not going to perform right rotation over 11. Okay, because we already marked the corresponding positions that we should perform rotations. Okay, see, I already has been marked those corresponding pointers or locations. So I already perform left rotations. Then I'm going to perform right rotation over this 12. I'm not going to perform right rotation over 11. Okay, I know this is imbalance itself, but the cases won't work that way. The cases already follow the specific mark order of that corresponding previous tree. Okay, so always follow that corresponding order, otherwise you will make some invalid tree. So if I perform a left rotation, uh, so left right case, so I perform left rotation. Now I'm going to perform right rotation. Okay, because this is the left right case, so I already performed left rotation over 10. Now I'm going to perform right rotation over 12. So it will make this new tree, so 12 will go downside, and that's it. So 11, 10, 5 and 12, because there is no no additional nodes to be attached to this 12, so it will make a tree like this. So let me consider the balance vectors as again, so 0, 0, 1 and 1. Again the tree is balanced, so either of the both cases are correct, can be chosen as the valid cases, and those are make a balanced AVL tree. So that is how we perform deleting operations over AVL trees.